Hello, today I'm going to show you how to do some echo type problems. And they're using sound as it bounces off and comes back. A couple things you need to know in order to do this. You need to remember that the velocity is distance divided by time. You could also write that as the distance is the velocity times the time, or you can also write that as the time is the distance divided by the velocity. That's the main tool you got to have. But with echo type problems, the key feature, which makes them a little bit unique, is a factor of 2. Okay, so you're gonna have to realize that the common mistake people make is they don't put in the appropriate factor of 2. Now I'm going to draw a diagram that'll show that here. So what we have, number one, a man stands at the edge of a 450 meter wide canyon and yells. Okay, so I'm going to draw a little picture here. Here's a man, canyon, and he yells. So the sound goes out, and then it bounces off the other side and comes back. Now, in this particular one, it's 450 meters wide. The common mistake people will have is they will say, oh, the distance is 450 meters. No, the distance is twice that. So we would write is the distance would be 450 meters times 2, which would be 900 meters. The time we're going to find is a down and back time, so we need to use a down and back distance. The speed of sound in this particular case, speed of sound is temperature dependent. In this case, it's about 340 meters per second. And therefore, what we are after is we want to calculate the time. So the time is going to be 900 meters divided by 340 meters per second. You'll notice that the meters in the numerator cancel denominators. You have seconds in the denominator of the denominator. And when you take 900 divided by 340, you will end up with 2.65 seconds. Okay, 2.65 seconds. Once again, the key thing is knowing that the relationship and the factor of 2. The factor of 2 is the key thing, the common mistake people make. Let's look at number 2. The speed of sound in fresh water is 1480 meters per second. That's dependent upon a lot of factors, but in this case, I'm giving you a value of 1480. It's a lot faster than it is in air. A ship sends a sonar signal from water level to the bottom of a freshwater bay. It took 0.18 seconds to receive the echo off the bottom of the bay. How deep is the bay? So now in this case, we're trying to find the distance. So we're going to draw, let me draw a little picture here. There's my water. There's my ship. And it's going to send a sonar signal down, which is a sound wave. It's going to bounce off the bottom. They're going to receive the echo. Okay. And what we want to know is how deep is the bay. So this is common for if you want to find the depth of the bay or the ocean, or you want to use a fish finder and you want to, how deep are the fish? You bounce the signal off that. So we have a velocity of 1480 meters per second. And you have a time of 0.18 seconds. And so the distance that the sound wave could go in that amount of time would be velocity times time. That would be 1480 meters per second times 0.18 seconds. Seconds in the numerator cancels seconds in the denominator, and we would get 1480 times 0.18 is going to be 266.4 meters. However, that's the down and back distance. We want to know how deep is the bay. So we don't want 266.4. We want to divide that by 2, and that'll give us 133.2 meters. So once again, the common mistake is to be off by a factor of 2. So always, whenever you do an echo problem, really look at, hey, how have I taken into account the factor of 2? And some people will go the wrong way. They'll end up taking the 266.4 and they're doubling it. So the diagram is really helpful in this. So let's take a look at the third one. The speed of sound in air is less when the air is colder. So on a very cold morning, I clapped and heard the echo 0.4 seconds later. The wall is 65 meters away. Find the speed of sound. So I'm once again drawing the picture would be very handy. So I clap, and the sound goes out to the wall, comes back. So what we get is we are 65 meters away from the wall. So the distance that the sound travels down and back is 65 meters times 2, or 130 meters. And then what we do is we say the time down and back is 0.4 seconds. And so the velocity of sound would be distance divided by time. 130 meters divided by 0.4 seconds. And that would give you 325 meters per second. So we're using that equation. Velocity is distance divided by time. In each of these problems, 3 types of problems, one solving for distance, one solving for time, in this case solving for velocity. But in each case, we need to really make sure that you take into the factor of 2 into account in the appropriate way. And I think the best way to do that would be to make sure you draw a diagram. Hope this helps. There's a quiz for you. I got homework problems as well.